All right, so what we're going to do here is going to find the graphs of two wonderful functions, the tangent graph and the cotangent graph. And so to begin, I'm going to get my little thing right here. Let's talk about tangent. Well, tangent, as we know, is sine of x over cosine of x. Now, one cool thing is that whenever you have a function, which is a quotient, we know that some things do not exist. For example, whenever you have a rational function, you cannot have 0 in the denominator, no 0 in the denominator, okay? And so what we have here is when you do have a 0 denominator, what it creates is what we refer to as a vertical asymptote. So whenever you have a number over 0, that is generally a vertical asymptote. 0 over a number, that is a 0. Okay, so when we're graphing this sine function, we can think of all the different values when we go around and look at what we did like for sine and cosine. We can think about the unit circle, and we go around here, and here's my unit circle. And at these different points, I got 0, we have 1 and 0. We have right here, which is going to be 0 and 1. Over there, it's going to be -1 and 0. And then right here, we have 0 and -1. So when we go around this circle, we can see that, okay, when we try to make little graphs of this, okay, and we start at 0, 0. Well, we take sine, which is the y, over the x. So if I start at 0, we have y over x, which is going to be, well, 0 over 1. Okay, 0 over 1 equals 0. Okay, we have a cool point there. Now we go to the next one, we go to pi over 2. Well, pi over 2, we have sine, that's going to be 1 over 0, which is undefined. Okay, actually can't put an equal sign. Undefined there, which means that that is a vertical asymptote. Okay, so we go to the next one, we say, well, we'll go with pi, and pi, once again, we have 0 over -1, which is 0. And then we go to our next one, which is going to be 3 pi over 2, and you realize we're going to have -1 over 0, once again, undefined, which is a vertical asymptote. Now we can go to pi over 2, and it keeps on going around, 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 around. So what do you notice about this? Well, first off, when we graph this, we realize all the tangents are positive over here at 0. So I'm going to just draw this right here. Okay, so I have my one point here at 0, 0. And then over at pi over 2, okay, we have a vertical asymptote. And I'm going to put a vertical asymptote here. It goes. That's how I make my vertical asymptotes, just so you know. All right, then we go over here. We have pi. Pi is going to be another 0. And then we have over here is 3 pi over 2. And that's going to be another vertical asymptote. Okay, and it keeps on repeating. Now, when we start over here, well, we really want to have one period. So if you realize this, we see that we can kind of draw this. We say, okay, first quadrant is positive. So if you know anything about vertical asymptotes, they approach the vertical asymptote. So it goes like that. On this one side, then we go to the second quadrant. Second quadrant, we have a positive over a negative. And so it's going to be negative right here. So it's going to go like this. And then we go into here, which would be negative over negative, which is positive. And then we keep on repeating. And so now we go to 2 pi. Once again, we have another 0. Then we can go to the next one in order. All right, we have pi over 2. We have 3 pi over 2. We can go 5 pi over 2. Okay, 5 pi over 2. La, 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 la. All right, and we realize that, yeah, we have another one, which goes to negative and then goes positive. And we have this keeps on going up like this. So now the thing is that this is also a periodic function. The period, though, you see, is that it's actually from pi, because it goes pi over 2 to 3 pi over 2. It's one whole pi. So the period of tangent is pi. That is the key thing here. Period of tangent is pi. Unlike sine and cosine, there is no amplitude. So right here, we're going to go negative pi over 2 right there. And so we go like this. Okay, and we have another value like that, and it keeps on repeating. So really, the first values we want to do, even though I started here at 0, we actually like to go, okay, from negative pi over 2, which is going to be a vertical asymptote. Okay, it's my x, my y. All right, from here to pi over 2. Always going negative because we see that from 0 to negative pi over 2 is the fourth quadrant. We have negative over a positive. That's why it's negative there. Okay, yeah, and that's tangent. So tangent has 0, 0, and then it goes in kind of like a cubic function way, but it has asymptotes on each side, so it doesn't. It's not like a polynomial. Now cotangent is very, very similar. Very, very similar. Okay, and what you see with cotangent, all right, is that cotangent is cosine of x over sine of x. And so the things are just going to be a little bit changed up a little bit. So if I go through the same process, and let's say, okay, well, let's see what happens when we go negative pi over 2. All right, and I go to 0, and I go pi over 2, and then I go up here at pi. Okay, and we go 3 pi over 2, and so on and so forth. All right, I'm just getting negative pi over 2 because you know that's what happened in the other one. So if we do this, what do you notice right here? Well, we're going to have 0, all right, 0 over negative 1, okay, because it's x over y. At 0, we have, a 1 over 0, undefined, a vertical asymptote. So when we graph the cotangent, we see that we have a vertical asymptote here. Go at 0. At negative pi over 2, we'll have a 0. And then we put in pi over 2. Well, it's going to be 0 over 1, 0 over 1, which is 0. Okay, that's cool. I'll change this up a little bit. All right, so that's pi over 2. And then we get the pi. Well, once again, pi, that's going to be negative 1 over 0, which once again is undefined, a vertical asymptote. La, 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 la. And so we see this is a little bit different. So over here, once again, you have to kind of think about this from 0 to pi over 2. This is the first quadrant. Well, cotangent is positive in the first quadrant. That's why it goes up like that. And then from pi over 2 to pi, it's going to be negative because it's going to be negative over a positive. So it's going to be negative. And then it repeats onward and so on and so forth. So right here, this is going to be negative. And then we can go to negative pi right there. La, 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 la. All right, and we go up. And you see that it's almost like a little reflection, all right, and shift from the tangent graph, And so each one of these, we can see that, okay, vertical asymptotes. Well, each one of our vertical asymptotes, it appears, okay, is going to be, well, x equaling, if we have this, pi over 2, okay, plus n pi. All right, n pi. So what we're going to do is just going to add this. So every pi over 2 n pi will have a vertical asymptote. Over here, we realize that, well, really it's just n pi. So every value of pi will have a vertical asymptote. So these are vertical asymptotes. That's how we define them. Okay, n is any integer, so you just keep on adding or subtracting. I probably should add and subtract there. All right, and we just keep on adding and subtracting any value for n pi there. They're vertical asymptotes. Okay. So that's how we define them. So vertical asymptotes are pi over 2, because that's where it starts, and then every pi, all right, value after that, all right, n pi back and forth, that's where we get there. Max or mins, there are none. There are no max or mins, unlike cosine and sine functions. The range here, well, for the tangent, well, the range is all real numbers because you see that it goes all the way up and all the way down because of the vertical asymptotes. The domain, well, the domain is kind of defined with the vertical asymptotes. So right here, this domain for the tangent are all reals, except x can't be the vertical asymptote. So we say basically x can't equal pi over 2 or any multiple of that pi over 2 n pi. Okay, so we just find that. The same thing for our domain here. All right, the domain would be x values cannot equal n pi. Okay, n pi, we can't have that. Okay, and so what we have here is this is how we get the graphs of tangent and cotangent. So tangent right here, vertical asymptotes at negative pi over 2 and pi over 2, and any multiple of pi. And then over here, we have cotangent, which starts at 0, and then at pi, those are those. Both have periods of pi, but have slightly different because where their zeros are going to be slightly different because of the quotient you have there. Okay. All right. Well, I hope this helps you out, and we're going to do some more graphs of tangent, cotangent in just a little bit.